Hi. Okay, so this video I'm just gonna um make the sigmoid function and we're gonna initialize parameters. So just import numpy as np and we're gonna make a function called sigmoid and we're gonna put in z in here and we're gonna say s for sigmoid is equal to 1 divided by 1 over numpy exponent of negative z, and I'm gonna close that. And sorry, I don't know why I did over, it should be plus. I'm just gonna go ahead and return the sigmoid function. Oh my, what is going on with me? What the fuck? Okay, yeah, so I kind of want to make sense of that, so I wrote 1 over 1 plus exponent of negative z in my code. I obviously used numpy and stuff, but you get the point. So that's 1 over 1 plus numpy.exponent, which is just e. Oh, sorry, 1 plus 1 plus exponent negative z, and exponent is just something or something to the power of whatever. Okay, and now I'm just gonna make a function for what is going on with me today? I honestly don't care about misspelling. So I'm gonna make a function for initializing our parameters, and I'm gonna say w shape. So I'm just gonna say w is equal to numpy dot random dot random, where I'm gonna say it's by w shape and 1, and I'm gonna say 0.01. I'll explain that in a second. And I'm just gonna put b to 0, and I'm gonna assert w shape to equal to w shape and 1 by 1. So w shape by 1, and I'm just gonna go ahead and return w and b. Okay. So the reason I actually did w equals numpy dot random, and then I actually like multiplied it by a small number is obviously so when you multiply a number by a factor of 1, you obviously get a close to a very small number, right? So you get a really small number. So keep that in mind for the times of 0.01. So I'm gonna print this super fast. So as you can see, it's a 2 by 1 shape because I passed in 2 right here. But that's gonna get removed in a second because w, we're gonna set w to our input x shape, and I'm gonna explain that in a second. And it turns out for like neural networks, you can actually set w to a we can set w to random values, right? But we can actually set our bias to 0. So w is our weight. We can set our bias to 0, but our weight has to be a random value, so then gradient descent can work it down. And here I'm just asserting it to be by w shape in 1. So the reason I put 1 is so it becomes a column vector. As you can see, it's a pretty much a column vector. So, and I put 1 so it avoids rank 1 errors. If you don't know what that is, Google it. So as you can see, it's a 2 by 1 shape. 2 because I passed in 2, but we're going to change that. And it has 2 random values from the random.randin. And then I multiply that by 0.01, which gives us this very small number.